Okay, we come to the open addressing methodology. Now let's look at the write-up. Says this involves finding another location for any entry which cannot be placed where its hash function points to. So when we look back to the bucket strategy, we had a table like this, and that table we had indexing position 1, 2, 3, 4, and so on and so forth. And so we had the spaces to place what we wanted to place. Okay, so in the bucket strategy, when we place maybe FHL here and we wanted to place XXS that evaluates to this same point, we were able to create another. We just created another array. We created another array, so that a column array, okay, that is attached to what we already have, so that we will be able to say, when you come to this place, refer to this index sub this index. All right, so all of these things are explained in that area. Now, instead of creating this, which we consume much space, the open addressing methodology states that the best way is to simply decrease this index. The hash index that we evaluated is 2. All right, so instead of you come to this place and you notice that 2 is already occupied, you just decrease it and you come to this place. When you note that this place is empty, you place your XXX there. All right, for instance. But if it is already occupied, you also move, and having come to the end of the array, you are now going to, at the beginning of the array, you will now go to the end of the array and continue. And this particular linear movement in the negative direction is called linear probing. Okay, that is linear probing. Now, a better approach is to search for any empty location using a secondary hash function, and we will understand this when we see what actually is the drawback of linear problem, which is just to primary clustering and secondary clustering. Okay, now explaining that linear problem with a figure. Now look at it. We have this to implement, and we noted that HKG is evaluated to index position 4. So we have this 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we come to index position 4 and noted that PHL, please don't mind the I, PHL is already in this position. Okay, so we decrement by 1 and then probe to know if something is already here. When we noted that something is not here, we placed our HKG. Okay, so in the next iteration, we noted that GLA evaluated to 8, and so we find the index position 8, and then we saw that something is already in the index position 8, so we go backwards by decrementing the index value, and we saw that we have 7 and it is empty, so we place our GLA. The same thing we did with AKL, but when we came to this place, we noted that something is already there. We moved to this place. We noted that something is already there, so we moved to this place only to find space in index location 5. That's why we placed it there. And that is how all of these things are placed. And when you look at this, you will notice that we actually do not have space to waste here. So every hash table that uses open addressing mechanism must have an empty location when it will be declared full, so that at insertion, when you see an empty location, you know that you have actually come to the end of the array, the end of the table. Okay, there is nothing else that you are going to insert. Or when you are searching for an item, when you come to an empty location, you know that actually there is no other space to search for. Okay, we will continue in the next session to look at what are the drawbacks of this